Hello everyone. Welcome to this new playlist on mathematics. Today we are going to learn about the Josephus problem. The Josephus problem is a classic problem in combinatorics and algorithm design. It models a deterministic elimination process in a circular arrangement. The problem is named after Flavius Josephus, a 1st-century historian. According to legend, he and his soldiers were trapped in the siege of Yodfat. They chose to die in a circular elimination, rather than be captured. At the end, Josephus survived. Let us consider 100 people standing in a circle. The first person eliminates the second person, and hands over the sword to the third person. If this goes on till only one person remains, who would survive? Let us run a simulation and figure out, shall we? Whenever a person is eliminated, they are marked in red. The eliminator is marked in blue, and the next person to hold the sword is marked in yellow. All other people alive are in green. As this proceeds, we can see that people are eliminated, and in the end, only one person remains. In our case, where there are 100 people, the person in the 73rd position survives. This may be a fun problem, but it has applications in scheduling, round-robin elimination, memory allocation or circular buffers, game theory simulations, etc. In a cluster where nodes are periodically taken offline for maintenance, a Josephus scheme avoids repeatedly impacting the same subset. Operating systems and network schedulers often use round-robin with skips. Instead of simple sequential scheduling, systems may skip tasks. This becomes equivalent to skipping every kth job. The Josephus formulation helps compute which job remains last. It also can come up with scheduling patterns without simulation. In systems where components fail cyclically, like stress testing hardware, or rotating backups, engineers may simulate the failure of every kth component. Josephus analysis determines which component survives longest, and whether the system topology introduces bias. Certain lightweight cryptographic or obfuscation schemes use deterministic elimination patterns, or index transformations based on cyclic skipping. Josephus-type permutations can shuffle indices in a predictable but non-trivial way. They can also serve as a primitive in encoding schemes, though not independently secure. Many multiplayer or AI simulations involve players eliminated in a circular pattern. There are turn-based mechanics with skipping rules. Josephus logic allows efficient computation of winner position and supports game balance tuning. In constrained systems, objects or processes may be periodically reclaimed using cyclic scans. If every kth object is removed, Josephus analysis predicts long-term survival patterns. Today we learnt about a common mathematical problem and its applications. I'll meet you again with another video. Until next time, happy learning!